you want straightforward chemistry for your exams, you've come to the right place. Let's dive straight into it. Okay, so we are looking at Dalton's atomic theory. Let's go. Okay, so first and foremost, you have to know about Dalton, right? You have to know that Dalton, John Dalton, all right, was an Englishman. He was an Englishman, and then through his studies, he made some statements, right? He made some statements about the atom. Some statements, sometimes they call them postulates, right? Or hypothesis. Okay. So give out some statements or postulates about the atom. And we are going to explore them in this lesson. Okay. So let's go straight to the point. I told you I always go straight to the point. All right. So the first thing he said was that all matter are made up of tiny indivisible particles. All matter. So an example of matter is maybe a substance of gold, right? A substance of sodium. You can talk about gases such as maybe neon, oxygen gas. These are all matter. So all these matter, all these elements are made up of certain tiny indivisible particles that we call atoms. So when they say indivisible, it means that when you break down a substance and you get to the atoms, the atom is the smallest. And the atom would not contain smaller particles within it. So the atom is the smallest indivisible particle. So that's the statement that he made. Okay, good. So let's move on to the next statement that he made, which was all atoms of the same elements are identical. All atoms of the same element are identical. So for example, when you have a substance, let's say this is a substance, a sample of sodium. Okay, sodium substance or sodium element would contain sodium atoms, right? A lot of sodium atoms. And Dalton is saying that all these sodium atoms within a given substance of sodium are all identical. That means their mass will be the same, their size and their behavior, everything will be the same. That was what he was saying. Okay, so they are identical. So they are identical because they belong to the same element, sodium. But when you take, let's say, a sample of, say, magnesium, it would have magnesium atoms. And you've seen that because all these magnesium atoms belong to the magnesium element or substance, they're all going to be identical as well. Okay, so that's the meaning of the first statement up to here. That's the meaning of the first statement. All right, so is that all? No, it continues to say that, but atoms of different elements are not identical. Atoms of different elements are not identical. That means that when you take a sodium atom from here and you take a magnesium atom from there, because they belong to different elements, they are not identical, right? They are not identical. Good. But all sodium atoms are identical, all magnesium atoms will be identical, but they'll be different from. So that's what he was saying. The sodium and magnesium are just examples I'm using, but I hope you get the concept he was trying to put forth. All right. Now let's move on to the next one. Okay. So the third statement he made was that atoms of different elements can combine in simple whole number ratios to form compounds. Okay, atoms of different elements can combine in simple whole number ratios to form compounds. So for example, let's say you have an element sodium, okay, and then we have sodium atoms, a lot of them making up the sodium element. Then let's say you have chlorine gas, a gas of chlorine, and then it also be having chlorine atoms, right? So what he's saying that you can have a sodium atom, which is an atom of one element, and then a chlorine atom, which is also an atom of chlorine. Okay, they can come together to form a compound, like let's say sodium chloride. But there's a way they do it. They do so in simple whole number ratios. So when you take the sodium chloride, looking at the chemical formula, how many sodium atoms do we have? Only one, and chlorine is also one. So the sodium and the chlorine have combined in a ratio of 1:1. So atoms of different elements will come together and they would form compounds. But when they do so in simple whole number ratios. So for example, water. So water here has 2 hydrogen atoms combining with what? 1 oxygen atom. So that is the idea. Atoms of different elements can come together to form compounds, but they do so in simple whole number ratios. Okay, so that is it. Let's move on to the next one. Okay, so we are moving on to the last one, the last statement. So here he says atoms can neither be created nor destroyed. Atoms can neither be created nor destroyed. So what did he mean by that? When you check the number of hydrogen atoms here, because it's balanced, you have 4 hydrogen atoms, and then oxygens, there are two oxygen atoms. Then here 4 hydrogen atoms against 2 oxygen atoms. So at the end of any chemical reaction, you have to have the same hydrogen atoms you had in the beginning at the end. So here you have 4 hydrogen atoms, at the end we have 4. In the beginning we had 2 oxygen atoms, at the end we have 2. So that's the reason why we have to balance chemical reactions. So he was just saying that in a chemical reaction, atoms can neither be created nor destroyed, and that is what he meant. Okay, so if for example you have 4 hydrogen atoms here, and then when you balance it's 2 hydrogen atoms, that means that 2 of the hydrogen atoms have been destroyed, and that will not happen. All right, so it's not just about forming an entirely new atoms. It also means that the quantity or the number of atoms that is present in the beginning should also be present at the end of the chemical change or chemical reaction. So that is what he meant by that. This is quite long, but it's worth our time. Okay, so that is it. These are the 4 postulates that he put forth. But one thing that I want to bring to your notice, normally we also talk about limitations and corrections to the Dalton's atomic theory. So now you know there are 4 things that he has said, but are all of them still 100% true in our modern day? No. So after Dalton came up with these things, later on further studies and further discoveries brought to light that some of the things he said were not 100% correct. So there are limitations. Okay, here we are going to talk about the limitations. Talk about the limitations and correction of the Dalton's atomic theory. Limitation and correction of the Dalton's atomic theory. Okay, so what are the limitations? Let's go. So first and foremost, he said that all elements are made up of tiny indivisible particles. So this one here, what do we have here? Here he was saying that they are made up of atoms, tiny indivisible particles. That means that he was saying that atoms are indivisible. But now we know that that is not true. So that's our first correction. Atoms are actually divisible. Atoms are divisible. Unlike it was proposed by Dalton. Now we know that atoms are divisible. Why do we say that? We say this now because we know from further discoveries that when the atom is not the smallest, because atom has yet subatomic particles. So the atom contains protons, electrons, and neutrons. All right. So because of that, we can say the atom is not divisible. It has components: protons, electrons, neutrons. So these are subatomic particles. Subatomic particles. So because the atom has subatomic particles, we can no more say it is not divisible, but it's rather divisible, right? Atoms are divisible. So this is correct. This is not correct. So that's the first correction that we make with regards to the things that Dalton brought forth. Now let's look at the second one. All atoms of the same element are identical, but atoms of different elements are not identical. Is that true? All atoms of the same element are identical, but atoms of different elements are not identical. Let's see. Have you heard of isotopes? Okay. So isotopes are atoms of the same element. So for example, when you take carbon, the element carbon, there are different versions of carbon. We have carbon that has a mass number of 12. We have another carbon atom that can have a mass number of 13, and one that has a mass number of 14. So even though these are all atoms of carbon, their mass numbers are not exactly the same. So that means that this first part where he says all atoms of the same element are identical is also false, because of the existence of isotopes. So you can have atoms belonging to the same element, like these ones. They belong to the same carbon element, but they have different mass numbers. They are not exactly the same. So this explains that what he said was not 100% accurate. Okay, so that's the second correction. Now we can look at the third one. So the third one here, he said that atoms of different elements can combine in simple whole number ratios. There's no problem with this one. We can go. Now let's look at the fourth one. Let's see if we can correct the fourth one. It needs some cleaning here. All right, so here, this is the fourth one, and it needs a correction. Okay, so later on, we got to know that through a process called radioactivity, which is an example of a nuclear reaction. Okay, so through radioactivity, you can have atoms being created and being destroyed. So that's a limitation. So it means that when we go beyond chemical reactions and we enter into nuclear reactions, atoms can be created and they can be destroyed. So for example, let me give, maybe you've not done radioactivity. That is another topic for another time, but let me just illustrate that with an equation. So let's say you have carbon 14. This is a very popular equation to depict radioactivity. So here you have carbon 14 releasing a particle. When it undergoes radioactivity, it can release beta particle. And when it does that, it can form an entirely different atom, which is the nitrogen atom. Okay, so this is an example of a radioactivity process where you have carbon turning into a different nitrogen. So it means that the carbon is destroyed and then the nitrogen is created through this process. So that also corrects the fourth statement of Dalton. So there you have it. I hope you've learned something. We've talked about the four postulates, and I've given you the corrections and limitations to some of the things that he said. Catch you later in another video. So there you have it. I hope you enjoy this lesson. I told you it's going to be straightforward. I want you to watch all the videos if you want to really pass your chemistry, and I want you to comment and tell me how it went. If you're enjoying this, let me know. Don't forget to like, don't forget to subscribe. Take care. Bye bye.